Hello, you are welcome back to my channel. In today's class, we want to continue from our last episode where we started talking about mirror and where we went further to discuss about the ray diagram. And we said in the ray diagram we have the application where we use the ray diagram to solve some questions. Now in today's class, we want to see how we can use the mirror's formula as well as the sign convention. You are welcome on board. Now the mirror's formula states that we have 1 all over u plus 1 all over v is equal to 1 all over f. Fine. What does these parameters, what do they stand for? Anywhere you see u is object distance. U is our object distance. Object what? Distance. V is image distance, and of course f is our focal length. Now anytime you are asked to calculate the object distance, invariably you are asked to find u. Anytime you are asked to find the image distance, that is v, and of course we have f standing for focal length. Now we have magnification. We talk of, you often hear the word magnification. So magnification is represented by m. That is, m is magnification. And what is our magnification? Our magnification, m, is equal to image distance all over object distance. Also, m is same thing as image height all over object height. Now, you must not get it confused. Anytime they are talking of magnification, image comes first. Whether the distance or the height, always talk of image first. Do not make mistake of putting object on top. It is always image. So, we can now say our m is also giving us, what is our image distance? Image distance is a what? That is v. All over, what is our object distance? That is u. So anywhere you see this, that is a magnification. We have this as our magnification. Also, our magnification again, we can say is image height all over object height. That is also our magnification. So now, since magnification is v all over u, and also magnification is IH all over OH, I can now say my m is equal to v all over u, which is equal to IH all over OH. So I want you to hold this. We shall be using this in our subsequent calculation. Now, let us represent this in a diagram. I know students usually get it confused. That is, which one is u, which one is v from the diagram. Now, if I draw it like this, I draw like this. Remember, we said this is a concave because the outside is coated. Now we have our pole. This is our principal axis. Principal what? Axis. And I told you it's an imaginary line. Now here we have our F, and here we have our C. If the distance from here to here is 10, it means from here to here is also 10, because F is half of this R. Now, if I place an object here, you can see this is my object. Now, what do we mean by the object distance? That is the distance of that object from a what? From what? From the mirror. So this one is going to be our U. Are we there? Now, and do not forget, if we have our image, let's say we have our image here, this one is going to be I, standing for image. U, standing for object distance. Object distance is a what? U. Image distance. So it means from here to here, let me use something to denote it. It means from here to here is our V. While from here to here is our U. Because this is our object distance. From where? From the mirror. If you are dealing with lens, you say from the lens. So object distance, image distance. So now our magnification we now say, we say the what? V all over U. That is image distance all over object distance. Are you there? Image distance all over object distance. So that is our magnification. Now at times they can say the height. You know this one is going to be object height. This one is going to be from here to here is going to be our what? Image height. If I see compute image height to that of an object height, I will still have my magnification. I believe that is understood. Good. Really is positive. Are we there? That is really is positive. Then this one we have new Cartesian. New Cartesian formula. Convention. We have new Cartesian. They are just two. So whichever you apply, you are going to get it right. More often than not, we usually use real is positive. So now, number one, focal length of concave mirror is positive. Focal length of concave mirror is what? Is positive. Here we have focal length. You can see, it's very interesting. Focal length of concave mirror. I want to simplify it for you. Is negative. You can see the difference. Under real is positive. The focal length of a concave mirror is positive. But for a new Cartesian, focal length of concave mirror is negative. So we go. The next one. Here we have focal length of convex mirror is negative. Why this man says that focal length of convex mirror is what? Positive. Number 3. Distances of real image and object Distances of real image and object are considered positive when measured from the mirror. I'm going to explain this with a diagram. And this one is telling us that distances measured to the right. Look at it. Distances measured to the right. You know I'm measuring. Distances measured to the right. That is, distances measured to the right are considered positive. Is that understood? Good. Number 4 now. Distances of virtual images are considered negative. Distances of virtual images are considered negative. Now this one is telling us that all distances measured to the left all distances measured to the left are considered to be what? To be negative. Yes, I have simplified it. Is that understood? I have simplified it. Now, I want to explain. I said I want to simplify it. I know you must have read this from your textbooks. You understand? But I want to explain what they mean by those concepts. Now, here is my, what kind of mirror is this? Of course, it's a concave mirror because I painted the outside. While the inner is for reflection. Now, I have my pole, I have my, what's it called? I have my principal focus, and of course, I have the curvature. Now, look at my object. My object is placed here. Remember the first one we said, let me take the first one, that is real is positive. Real is positive. We said, the moment you hear the word concave mirror, you don't need to be told. The moment you hear the word concave mirror, then it now means that my F is going to be what? Positive. My F is going to be positive because I've been told that it is a concave mirror. But if it is a convex mirror, my what is it called? My focus, the focal length is going to be negative. Salient point. You have to take notice of those points. Now, this is a concave mirror. Automatically, this one is going to be what? It's going to be positive. Now, well, let's go. The next one, this one is a real object. So, my U is going to be positive, because it's a real object. Now, this one too is going to form a real image. My image will be somewhere here. Remember I said, if it is at the back, the image will be in the front. If this one is in the front, the image will be here. Are you there? So now, this one too, my V here, my V, you know, if I want to measure it, how will I measure it? Of course, I'm going to measure it to the what? To my mirror. So, this one is telling us that Since it is a real image, my V is going to be what? It's still going to be positive. Under rest, real is positive. So it's telling us, that's what this one is telling us. That is, the focal length of a concave mirror is positive. Distances of real image and object, they are positive. I think that is understood. Now we have talked about the distances of the real and real object and image. Now, supposing you are having I have another sketch here. Let's say I have another sketch here. I have a sketch here. This is still a concave. This is still a concave mirror. I have my P here. I have my F here. I have my C here. If I now have my object here, look at it though. My object is here. Where will I have my image? Of course, my image is going to be somewhere here. At the back of the what? Of the mirror. So since it's at the back of the mirror, this one is a virtual. That is, cannot be, when you say virtual, it cannot be caught on the screen. Something that cannot be caught on the screen is called virtual. So this one is forming at the back. Now the distance of this one is going to be V here is going to be negative, because the distance of the virtual image is negative. Why this one is going to be what? Is going to be positive. Our focal length is going to be what? Is going to be positive. Are you getting now? Well, let's see. Which one are going to be positive? Focal length, positive. Object distance, positive. Image distance, negative. Because it's a virtual. It is forming at the back. Is that understood? New Cartesian, NC. Under NC, look at what this man is saying. Oh. The moment you hear, what kind of a mirror is this? Concave. You now say, okay, it's a concave mirror. No wala. F is going to be minus. The moment he hears that it is a concave, then it means our F is going to be minus. But if it is convex mirror, our F is going to be positive. So, now, look at this. If I want to measure this way, if I measure, this is object distance, and this is the image distance. How am I measuring it? I'm measuring it. What direction am I going? I'm going to the left. So it's now saying my U is equal to minus. Because I'm moving towards left. It's minus. This one too, if I have to measure it, you don't have to measure like this to the mirror. So this one, my V2 is equal to what? Is going to be minus. Are we there? This is what this man is saying, no? That is, all distances measured to the left, to the left are negative. That is it. Are you getting it now? So this one is negative, this one too is negative. And because it is a concave mirror, then F2 is what? Is negative. That's what he's saying. Oh yeah, look at it now. If I now have the second case here, look at the second case. This is our virtual image, Abby. If I want to measure it, I have to measure this way. Look up. I have to measure this way. It means I'm going to the right. So, this one, my V here is going to be plus, because I'm moving to the right. Why real is positive said is what? Is negative. They always oppose each other. If this man says this one will say the other way. I believe it's understood. Good. Now, a beautiful question. The question says an object is placed 15 centimeters. Oh yeah, let's see. Even without doing any calculation, I can assume, I will say, okay, an object is placed 15 centimeters in front of a concave mirror. So, I will now say, okay, I have drawn this. See, the one we did before. Here we have, now they said it's placed. Let me see my radius, my focal length. They did not give me focal length. Instead, what did they give me? They gave me radius of curvature. radius of curvature. And we know that our radius of curvature is equal to what? That is our f is equal to radius of curvature divided by 2. What is our f? Our radius of curvature is what? 20. So I will say 20 all over 2, which is what? Which is 10 centimeter. Very beautiful. So if I say my focal length, this one is 10 centimeter. From the question, we were given the radius of curvature to be 20, the object distance to be 15. Of course, this radius of curvature, we are going to get our f. You know, from the formula, we have f is equal to r all over 2. F is r is 20, because this is our r, 20 all over 2, which is what? 10 centimeter. Fine, we have found this. So it means this one now has now changed. It has become 10 centimeter. Now we can use our mirror formula to get our v. So we have 1 all over f is equal to 1 all over u plus 1 all over v. Remember, it is a concave mirror. Our focal length is positive. Again, object, real object, u is going to be positive. And our image, of course, is going to give us, you know, if we quickly look at the ray diagram, we have this. So that this one will show me if I'm right or I'm wrong. Here we have P, we have F, we have C. Now, where is our object? From here to here is 10, Abi. Here is 10. Definitely here is 20, Abi. Our 15 should be somewhere here. So since it is somewhere there, then you know it is at the back here. So this one is now coming to this place and it's going to be magnified. So it means this, my object distance to is positive. So I will use my formula. 1 all over f, that's 1 all over 10 is equal to 1 all over 15 plus 1 all over v. And this one will give us, if this one goes here, what do you have? We have 1 all over 10 minus 1 all over 15 is equal to 1 all over v. So what's the LCM? The LCM, of course, is 30. We have 30. This and this we have 3. Minus this and this we have 2. Is equal to 1 all over v. So this one will give me, that is 1 all over 30 is equal to 1 all over v. My v, therefore, now is equal to 30 centimeter. Class, what did I say? I told you that it's going to be magnified. Look at it. Sorry, this is the distance. Well, let us see whether we are right or we are wrong. What's from here to here? 10. From here to here is 10. That's 20. Now, class, is my answer? Where did I say I'm going to have my diagram? You know, my image. I told you far from C. So now, definitely it cannot be here. My 30 is above that C. So that tells you that I'm right. You can now see that is the importance of my ray diagram. If you understand the ray diagram, of course you can know what to do. Now, we have talked about, we have found our V. What's now our V now? Our V is now 30 centimeter. Class, it remains M that we are looking for. But what is our M? M is V all over U. What's my V? That's 30. What's my U? That's 15. Class, what do you have? That is 2. Magnification does not have unit. Oh. Magnification does not have unit. It is unitless. Because this is centimeter. This one too is centimeter. Centimeter, we cancel centimeter. So it is 2. Class, am I right or wrong? You know, I told you that even before the calculation, I told you that it's going to be magnified. Can't you see? Look at the size of the object. Look at the size of the what? Of our image. This is the object. Look at the size. Is it not magnified? Magnified means it is bigger. Now, we have seen the magnification to be 2. Our magnification is 2. Now they now said we should, the position now, we have said that it is what? It's going to be 30 centimeter from the mirror. That's the position. The nature is going to be real, inverted. Are you getting now? Then our magnification, you know, is going to be magnified. By what? By 2. Are you getting now? So now you can now see our magnification is 2. Is that understood? Now the next one, we said we have two conventions. We have dealt with a real is positive. Let us now see how we apply new Cartesian. Now what is our radius? That is the radius we have. That is what do you have for radius? That is 20, right? We have 20, and our f therefore is going to be 20 all over 2, which is going to be 10. But remember, it is what? It is a concave mirror. So our f is going to be minus 10 centimeter. Now our object distance, we were told, is 15. How do we measure it? We measure it to the left. So this one too is going to be minus 15 centimeter. Are we there? So we don't know our v. Our v is unknown. Our m is also unknown. So let us now use our formula. The formula, that is 1 all over f is equal to 1 all over u plus 1 all over v. This one is going to be 1 all over minus 10, because this one is minus 10. Minus 10 is equal to 1 all over u. What's our u? Minus 15 plus 1 all over v. So if this one crosses to the other side, we have 1 all over minus 10 minus 15 is equal to 1 all over v. So what do you have here? We have 1 all over v is equal to, what's the LCM? That is minus 30, right? Minus 10 in minus 30, we have 3. Minus 15 in minus 30, that is 2. Are we there? So this one will now give us 1 all over v is equal to 1 all over minus 30. And when you cross multiply, v is equal to minus 30. That shows that we are very correct. Is it not negative 2? That's minus 30 centimeter. Is that understood? Magnification now is going to be v all over u. M is equal to, what's our v? We have gotten v to be minus 30 all over, what's my u? Minus 15. Minus cancel minus. M is what? Is also 2. Can you now see? In both cases, the magnification is 2. Is that all clear? Now, the question says, an object is 0. Please, do not make mistake. This is not V, oh. This is not V. I. That is how tall is the object. So I will now say, object height is what? Is 0.04 meters. Is placed in front. Look at it. Is placed in front. In front and at a right angle to the axis. This is the axis. To the axis. At the right angle to the axis of a concave. This is a concave mirror, which has a radius of curvature. It means our R is what? That is radius of curvature, which has a radius of curvature is 0.15 meters. And to get our F, we divide by 2. That is 0.15 divided by 2. That is 0.075 meters. That is our F. Then now, if a real image is 0.12 meter high, this one too is not distance. So this one, it means image height is what? Is 0.12 meters. Then they said we should obtain the distance. Is that understood? Now you can see our parameters. Now let us now see. They said we should determine the object distance. That is the question mark. Now we have to play about with these parameters and see how we can. I told you the other time that magnification is object distance, image distance all over object distance, which is equal to image height all over object. Here we are not giving object distance, we are not giving image distance, but instead we are giving the object and the image distances. So I will now say my magnification is image height all over object height. That's what we are given. We are only given the height of the object and the image. So we have our M. What's our image height? That is 0.12 all over object height is 0.04. And when you divide, class, this one is going to give you 3. I told you magnification does not have unit because meter must have cancelled meter. So we have gotten our magnification. Now, you have gotten the magnification. They ask us to now find the object distance. So it means I'm going to use the other side of the other formula for magnification, which is M is equal to V all over U. You can see from here I can get my object distance required. Now M is M. It means I will now say 3 is equal to V all over U. If you cross multiply, this one, our V now is going to be what? 3U. Beautiful. That is our 3U. Now, we now know from our formula that 1 all over F is equal to 1 all over V plus 1 all over U. Now, the fastest way of computing this, instead of doing this, there is another formula you can use to get your F without finding the reciprocal of F. And this one is same thing as F is equal to the product UV all over the sum. So, what is my product? Now, what is my U? My U is my U. What is my U? My U is my U. So, I have U times, what is my V? My V is 3U. So, I will say 3U all over, what is my U? My U is my U. U plus, what is my V? My V is 3U. And this one will give me 3U squared all over what? 4U is equal to, what's my F? My F is 0.075. Are we there? So, U here, we cancel this. Am I speaking, class? Is that understood? Now, class, I have brought what I have here to display for clarity. Now, if you multiply, if you cross multiply, this one will give you 0.3 is equal to 3U. Divide both sides by 3, this one by 3. This cancel this, we have U is equal to 0.1 meters, which is equivalent to 10 centimeters. Now, if you understand, if you enjoyed the topic, please do subscribe to the channel and like the video. Thank you.